changing my ways, counting the days. I'm so messed up, running away, starting to fade. Cause I know the truth. Got me slipping. Back on the road, I didn't know where the bus would stop. Out of control, how could I know that I'd be with you? Wasting my time, cheating and lying. I'm so screwed up, losing my mind, bitter, unkind. I'm black and blue, just existing. Flying away, nowhere to stay, no place too far. Into the sun to overcome. I'm coming home, where I belong. Scene, loaded and clean, already drunk, angry and mad, bitter and sad. I'm black and blue. Guess I'm slipping. Finders of girls had the whole world. I was on top, no place to run. I come undone, don't know what to do. Something's missing. Breaking the rules, playing it cool, it's getting tough. Finding your way ain't easy these days, and I'm here with you.
Hello everybody. Welcome to the fourth day of the Liberate Data Week. Today we speak about free press and publishing. It's a bit shorter program planned for today compared to the previous days. More to just give like quick updates, what are ongoing activities around this with Swarm. As the first talk or discussion of today's session, a discussion with a special guest was planned. Unfortunately, this guest won't be available. It's not possible for him to join us today. So we will make up for this at next occasions. But we do have also some new things, more than we announced at the end. We will see already some results coming from the hackathon itself. So the plan for today's session is we start first with Dan, who is going to give us, explain us how to host a website on Swarm, followed by Zahur. Zahur will talk about how we are working on getting OpenStreetMaps onto Swarm. And last speaker for today will be a quick demo from Tadej, who's been working on FairOS UI, web UI. I had the chance and opportunity to see it yesterday and was completely blown away. And yeah, we should be sharing it with you guys. So maybe now we can just continue. Dan, are you here? Please join me.
I am here, but I can't start my video. Hi, guys.
It's all good. It's all good. No worries. Okay, even better, even better. So maybe then before you start with the talk, it's I think what is also important to say, you are probably the person who uploaded most to Swarm in most ways for the most longest time. So you're like the man for these kind of things. And how do you see it now in the past months, even years, this change from the old Swarm network to the new Swarm network, and where do you see it going?
Well, I've just been spending some time with Attila, who's the BJS lead. And I think like really that is it's the most exciting bit really. So these JavaScript tools are something that we never really had before. And so we were kind of like making do. But now we've got a bit more juice behind us, then I think like it's going to start to get really exciting really soon. It's interesting moving from old Swarm to B, because B is a lot more efficient in a lot of ways, but I think a lot of the edge cases have not been found out, whereas Swarm is a bit more of a mature software. So I think we'll see in the coming months everything coming together and coalescing into hopefully like a highly efficient and mature infrastructure for building dApps, and then to be able to do stuff like this, what we're talking about today, in terms of providing censorship proof and sovereign ways for people to distribute their important journalism and so on.
Yes. So, you know, it's like we both know like services like Netlify or similar ones. And my understanding is a lot of these, let's say, front-end movement guys who are into static websites, for example, they do it because of speed. Now, do you think that Swarm, besides providing this censorship-resistant platform, will it be able to compete in the future also on the speed side of the things?
I mean, I think that's always going to come secondary. You know, it says in the book that B-line delivery is planned, but with that, then you lose some of the, you know, sort of Tor, onion router kind of elements of Swarm. So we're never going to try and have this initial retrieval to be as quickly as possible. Of course, like once you've got it on your local machine, then it's insanely quick. And in that way, that it'll become much quicker. So it depends really on the exact use case. And I think as we sort of like start to re-architect where data is stored and how it's moved around the internet, then we'll find that these sort of like benchmarking models will completely change, because it's a different paradigm. It works in a different way.
Awesome. Thank you for the answer. So I won't keep you up more, because I know you also are on a tight schedule, and maybe we just switch now to your talk. How do we get a website running up on Swarm?
Indeed. All right. Well, I was taking it to the wire on this one, I'll tell you. So I'm still kind of like halfway through preparations, and even the stuff is being built as we're using it. So what I'm going to do is I'm just going to give you a general rambling overview of where we're at.
Awesome.
But I mean, hopefully it's more in line with the hackathon element. I've not closed down.
Exactly. That's the best we can ask, you know, that the info comes straight from the source.
No,
so,
I've not tidied my desk. This is what my desk looks like. Sorry for this.
All right. Switching my camera off. The floor is yours.
Okay, cool. So let me try and make this relatively coherent for you guys. So this is for anyone who's not seen it. This is what the ENS domains app looks like. And I've got this connected at the moment via MetaMask to the Girly test network, because ENS updates cost around $15 a time at the moment. So it's kind of expensive at enterprise to do testing on the mainnet. But fortunately, ENS also works with Gurley. And if you go into my account, you'll see I've got 2 domain names here, and you can actually like buy these on Gurley as well. You search for them. Just like a normal domain site, register it. I won't do this now because it involves a 1-minute wait. You can maybe kick it off. Now, ENS domains is pretty good for the most part. It works well. Kind of one of the crown jewels of Ethereum, really, before the DeFi invasion. So anyway, if we go back and have a look, I've been experimenting here with this domain that I bought earlier, swarm.eth. And then if that completes, okay, I'll show you. But at the first time you come through this, you'll have to deploy what's called a resolver contract here. And then this is the bit that links with Swarm. Oops. The content hash. So if we go into the editing bit here, you'll see using the BZZ protocol, and there's content hash, and there's other, you can do Tor and IPFS also. Now, this hash relates to the manifest of the website once it's been uploaded onto Swarm. And there's bunches of different ways to do this. The old way and the way that's currently in the docs is to go into the directory. So in here, and then hopefully do something like this. So tar the website without compression. Yep. And then upload that. As you can see, I've done that quite a few times before. And this is just using the command line curl amendments. So this here you can specify in the headers the index document. So normally that's index HTML, right? And also an optional error document. So that's like if something, if a file is requested that's not in the manifest, then render this. And then here we've got an index HTML, which is how you deal with routing for single page apps like React and so on, where the errors are dealt with the internal router. And then so you see we've got a reference here. And then the idea is you can navigate to that reference. And that gives the website here. So what we would have done is taken this hash, put that in here, and update it. MetaMask is playing nice. Yeah, and then I've got my beast set up at the moment, the local version. Here you can see I've got the resolver options to be using the girly endpoint. So hopefully you can see that. Yeah, and what that means is it's using the girly ENS contracts, which interact with the girly ENS domains app. And that gives us, that means that when I go hopefully on here to thing, it should take me to the right website. So then the process for deployment here is, you just update this somehow, tar it again, curl it again, and this time we're going to get a different reference. So you can see this hash is different to this hash because it's uploaded a whole new directory, structure, manifest, and all of this. Here we would see 2 exclamation marks, and we come in here and change the hash. Now this is the step that costs at the moment $15 worth of gas on the Ethereum network. And the good thing about this is there's no need to wait for propagation as is with normal DNS. Once the transaction syncs the network, it's synced. You see now we've got 2 exclamation marks here. So it's done the update. And as I've said multiple times now, this is extremely expensive. So we've got a solution for this. And so we're still working on it. It's very kind of like bleeding edge at the moment. So we're still like ironing out some difficulties, and I'm using a dev environment. But I'm going to show you what is the solution to this gas problem. I'm just interested to see what's going on with my other registration. Guess that doesn't. So this is what I've been doing with Attila, and I can show you here for the extra technical. This is us trying to work out how to do it with BJS. And this is probably a bit more instructive rather than just going straight away to the punchline, which I'll show you in a minute. So in Swarm, there is this concept of feeds. Now, feeds are a collection of single owner chunks that have a certain index, which we can determine based on kind of like pre-agreed rules. So there's a certain set of rules that the client and the gateway application abides by in order to say, this is the latest version of my website. And what we've done is when you navigate now to an ENS domain or a feed manifest hash, I'm going to explain in a moment, B will go into the network and work out what is the last version of the website you uploaded and then display that. So that means that you just need to update ENS once with the feed manifest hash, and then B will know that it's a feed and then go search the network, find the latest version, display that to the user. And then when you need to update, then you just do a feed update, and that will enable B to know there's a new version of the website, which will then display. So as you can see in this code here, this is a good example also how easy it is going to be to interact with Swarm using the BJS library. just use like normal ES6 here. We like require, you just require the library, create a new one with the relevant endpoint, new instance of it. And then this is Node, just going to where my test site is, I just showed you, uploading the files from that directory recursively, setting the index stuff. And so this is instead of doing tar and the cal, it uploads it to a specific reference, which is returned from that command. So already this is way easier. And so you can do this programmatically using JavaScript, trivial levels of effort. Then we're getting into the feed bit now, which is a bit more complicated. So it has a private key. Of course, that's not a good way to manage keys, but it's just an example. The topic, which is essentially namespacing for the feeds. And then and this is like experimental API for BJS, but make a feed writer, create the manifest I've been talking about. Now, what this is this is a special chunk that is created in B. Created by B in the swarm. So when B finds this chunk, it knows I need to go and resolve this feed now. So I check. And the way it's working at the moment is as simple as there's just incremental indexes in the feed. So it checks, is there a chunk at feed 0, index 0? If there is, it checks 1. If there is, it checks 2, and then maybe it finds nothing and 3 and then returns 2. So that's what the manifest does. And then this feed writer actually goes and checks like what is the last available index, and then updates to the next one. So quite complex stuff, but we can see with this manifest reference here, if we take this and put it into ENS, then that is the last time that we'll have to update our website on ENS domains. So run that command. And you can see that. So I'll change the this a little bit so you can see some changes. Reference the little node script we're using there. So it's uploading it to this reference, so we can go directly to this one. This is the same as what we were doing before with Carl. So BZZ endpoint, which is kind of like the gateway. And by the way, I've got this just on an isolated local network now. But if it was connected to the network, the main net, then all of you would also be able to go to this hash address now and find this website, because it would be synced to the network. And also gateway.swarm.org and any other gateways as they pop up. And here it's listing out the manifest hash. So this is the manifest itself, and this is what we'll update ENS with. As I said, still teething problems, but forgive us. That's not quite updated, but that should be the latest version. And the single owner chunk itself is not important for this purposes of this. So the idea is when we get this, go into ENS, go back here, just to reiterate, edit the record, BZZ protocol, put in the manifest address itself, and send the transaction. You can monitor that on the scan. Watch as that gets mined into the chain. And then next time we go to this swarm, swarm, swarm. So it's not changed there, but it will change with the feed updates as the bugs get resolved. And then finally, there's one higher level abstraction, which is something that's hot off the press. So much so that I'm just running it here in a development environment. Let's see if it's going to work. We've got the Swarm CLI, so I think this is a premiere. I'm not sure. There's identity management, so that you don't have to include that private key as a string, or otherwise deal with the key management in your system. It stores in an encrypted v3, so you can create your identity. And this is the second time I've ever used this, so there's a good chance this might not come together. Ah, okay, great. So it's created a new identity. Then let's see what else we've been doing. So we can upload the file to Swarm. Suppose this isn't. Getting an insight into my terminal habits here. Ah, okay. So it looks like we just use directly the feed upload rather than just the static one. I'm kind of interested in winging it, so let's have a look, see if it works. Upload. I guess the identity doesn't matter for this. So it looks good, and this actually even has got a status bar to show like this is how it's syncing into the network. So first you'll upload to your local B, and then that'll slowly push the chunks out into the network to where the eventual place they'll be stored from is. And then, as we've spoken about, this feed upload, and it will do all of the steps above in one go. Very much looking forward to getting this into the continuous integration process in the Swarm team. Some changes, see how that goes. And this is important to note. When we're changing the website, the root hash of the manifest itself is changing, but the hash of the manifest for the website, but the feed manifest hash is not changing, and that's why you only need to do the one ENS update. So you can see if I run it again now, and they'll both be the same, so I've not made any changes. And then we navigate to this, you can see the changes implemented. Right, this probably won't work right now, but in the future, change this, then go back to the manifest, and the changes will be shown. But as I said, very much work in progress at the moment, but we're getting very, very close to being able to release this in a fully functional capacity. So yeah, watch this space. And I think that will probably conclude my rambling presentation. If Gregor, if you're there.
Yes, awesome. Thank you very much. It's we didn't think before this talk, and yes, I was hoping we will cover the feeds part, because, like you said, every update is quite costly, and actually, if we also want to have like websites that update faster than 14 seconds, faster than the block time on Ethereum, then we need feeds. So awesome. And it's been great for me to follow it through, because yeah, I hadn't seen it with the CLI tool already done, and I actually also didn't know how exactly to do it with the feeds and topics. So up to now, when I was publishing something, essentially I was the one paying ENS for every update. Awesome. Then is maybe the script that you have for creating the feed and uploading the website, is it maybe available anywhere as a gist or something?
I'm using like development versions of the JavaScript client at the moment. So, but yeah, anybody like get in touch via Mattermost or B support or Orange Lounge, and I'll pick that up. I'm happy to go through it with anyone and show you where we're at.
Really good. Thank you very much, Dan, for your presentation. My understanding is that unfortunately you cannot stay with us for later the AMA, but I'm sure we will see you around at the next occasion. And,
yes, I am always AMA, Gregor, anytime AMA. Cool. Catch you later. Thanks.
So I would now ask to the stage Zahur. Zahur is going to present his work on bringing OpenStreetMaps to the on the Swarm. Zahur, are you here?
I'm here, but I'm not able to start the video. It says, okay, no, I get it, I guess. Yes, okay, enable the permissions. Hello, hello.
Technical problems also. Can you hear me now?
Yes, we can hear you loud and clear.
Because from the technical room, I was told that my sound sucks, but it's actually probably just my voice, not technology. Can't help with that. So yeah, Zahur, you've been working on a pretty amazing things, and we've seen FairOS already this week. Every time we speak about FairOS, there's a bunch of new kick-ass features, really good, really empowering. But today we meet with a special purpose. Today we speak about OpenStreetMaps on Swarm by using FairOS public pods, right?
Yes, yes. So before I start, I have to say that whatever was shown by Dan in this previous demo is super awesome, and it's going to save a lot of money to me. And I would say thank you, Dan. I was about to do it otherwise. So yeah, yes, as you said. So the intention of this particular session is to show that how open data can be pushed into Swarm and can be consumed by other decentralized applications that actually make use of Swarm. So if you build any applications and store the application in Swarm, and it's totally decentralized, except it uses some centralized service to consume some data, right? We have seen a lot of applications like that. One of the very notorious one is actually maps. Even though we make a lot of software which is decentralized and this and that, we don't have a data provider, as I say, right? A decentralized data provider to power the apps. So this actually data need not be some special data that is being done by large organizations, but it can be anything, right? So let's say that I have like a huge collection of movies which I own, and I want to share that with the group of people over the internet. I should be able to actually share the data. I should be able to update the data. I should be able to give information to people so that they can actually consume that. But there are a lot of other data which are very important to applications, and I will speak when I give the presentation. Yeah, so this is what we are going to speak today. So today is more about how to store the data and make it accessible to other applications. And through this, what we want to say, what we want to communicate to the decentralized community is that now you have the tools, right? So if now you can actually put the data there and consume the data in a very decentralized fashion without depending upon any third party centralized services and things like that. So this is like a big step, and we want Swarm to be like a good place where you put a lot of data like this and make it accessible for public.
Yes, for me, this is one of the missing links. It's like we speak about the world computer, but then the data is being stored on Amazons and Googles and stuff. It's like we speak in the Ethereum space, we speak about NFTs and how they're linked to digital art. And then that digital art is again saved on centralized platforms. What does it help to me if I have a record of an NFT, but I cannot access the content of that NFT? So it's yeah, I guess once we go into the decentralization, sooner or later, one realizes that we need to go all the way, and putting data.
Exactly.
Putting data on decentralized storage is this missing piece. So, Zahur, without further ado, I will just ask you, show us what you got.
Yeah, I'm going to just share the screen now, and maybe you don't see my face for good. Okay, so I have like a couple of slides which speaks about this and how this was implemented and things like that. So as I said in the introduction, right, it's very important that we have ways to store data, access data, and make it available to applications. Only then it becomes a real world computer, as we say, right? Without the data, you can only run certain kinds of apps and not go the whole 9 yards, right? So I think so. This is this, if it inspires few people to put the data and maintain the data, and thereby they can get incentivized through actually Swarm incentivization and things like that, then I think we have done some good for the society. So okay, so using FairOS, as I said on actually the opening day. So the public pods are a way to enable anonymous data sharing over Swarm. So you you actually create a user in FairOS, and then you create a pod. Each pod has its own key value pair. And so you can just create as many pods as you want. And inside one of the pods, you could put all the data that you want to individually control. And then you can make it accessible by sharing the pod, right? So what are some of the data that that can be very useful to applications, especially decentralized application? As I said, OpenStreetMap, the map data. If we actually find a way to put OSM data, OpenStreetMap data, and also have some way of generating the tiles, which is my hackathon project, actually, by the way, then we had actually solved a way to access map data over the internet in a decentralized fashion. There are a lot of other data sets. I showed Ethereum transaction in the last demo, where I just inserted 500,000, the first 500,000 blocks, and it can be accessible. And I mean, I have a list, like we want to put Wikipedia like thing. In some countries Wikipedia is really not accessible. Like people from that country can access Wikipedia. And there is like a project Gutenberg, which is one of my actual favorites, where you put all the books which are free and in Creative Commons in a place, and make it searchable so that you could actually go and find it. Another data set that I really like is ImagineIt data set. This is the go-to data set to train any convolution neural network, to train a neural network to recognize objects in a photo. It can be any object, and this is a beautiful data set, like put together by a lot of people over the internet, and it's like close to one terabyte. Actually, it's very hard to download that much data and do anything on that. You need to have a serious hardware to do that. So if we have these kinds of data in Swarm, then I don't need to actually download. I just my application can access only data that is required, and it can just show the data if these data are indexed and accessible over Swarm, right? Okay, how can we store these data? As we said, there are three different ways to store data. One is you can just store raw data as it is in the file system and make the file system like public. Of course, this is not much useful, because raw data means people again have to search through that and do something over that. But this is useful for a few of the data like Wikipedia and things like that, where you just need to just take a page and just render it in the browser, and you don't need some very hanky-fanky, very fashionable data structure to actually do this. There are other data structures like key value and document store. Key value if you're using a simple index data structure. Document store, that if you want to do or search the data using multiple fields, right? Okay, so let's actually look about OpenStreetMaps. So OpenStreetMaps data is made available to everybody. So you can go and download the data, and every week there is an update. You can actually download the OSM files. These are in specific format. Inside that you will find, usually they come in XML file, and they come in three, okay, so inside that you will find three different kinds of data. One is actually called the node data. Node is a point of interest in a map. It can be a building, it can be a dam, it can be a cafe, anything, right? It's actually a point of interest. And then you will have information about the point of interest, like what is the lat long, what are the tags, whether it's cafe, if it is like a building, what is the name of the building, and things like that. And then the second kind of document that you will find is called a way. Way is a slightly bigger construct, where it is useful to represent more than one node. Something if you want to say like I mean a road or actually waterway or anything like that, so which is like some way, and then you can put different nodes along the way and then say that, oh, okay, so this is a way and there are different nodes along the way. Relation is a little bigger construct than way, that where you actually say that, hey, so I like like a, like actually a bus route, which can have multiple ways and multiple nodes along that. So right, so I give an example of these things. These are how it looks like that if you actually convert that into JSON. So a node, and then you will have an ID. Every node ID is very different. And then you will have the lat long of that and the different versions, because people update this. And then you will have, actually the tags. The tags will give information about this particular object. It can be a node, it can be a way, it can be a relation. In relation, you will have actually the members inside the relation. I'm sorry. So you will have actually the members inside the relation, like what you see here, the node, and then there is like way also. Like, I mean, if you take a bus route, bus goes through this way and this way and this way. Like, I mean, it can go through 3 different highway, and it can actually pass multiple nodes or a point of interests along the way, right? So this is how OpenStreetMap data structure is defined. So what I do is that, I have actually taken this data and sort of index this using actually the tags and actually the type, right? So what you can do is that you can actually build applications which can generate vector tiles by taking this data. And this vector tiles can be done from you can have a server-side application, or you can have a client-side application which can actually do in client, right? There are a lot of JavaScript and other libraries out there in the OpenStreetMap website, which will actually convert this into vector tiles or actually raster tiles, right? And then you can actually display in that particular environment. So, okay, so I'm speaking about indexes, and I want to give a small introduction about how I have built indexes, just for you to understand and appreciate and to know a little bit more how to really use this. So what I do is that, so when you index a document, I just created like a big file, let's say Switzerland.json, which has all the nodes and all the ways and all the relations of the country Switzerland, right? So each one of the lines here you see here is one JSON record, which indicates either a node, a way, or a relation. It is actually a pretty big file. Usually, like Switzerland is like, when you uncompress it, it's like 1.6 gigs. And it has all the information inside that. So when you upload this into FairOS, what FairOS does is that it splits this into smaller blocks. Blocks are something very akin to how Swarm deals in chunks, but chunks are way smaller. Blocks are slightly bigger, just to make sure that you could access these things without any big delay if you ask for something, right? So you upload this, and FairOS automatically splits this according to the the block size you give when you upload. Let's say the block size is 10 MB or something like that. If you upload a 1000 MB JSON file, so every 10 MB will be taken and it will be compressed and will be stored as a file. So each block will be a separate file in Swarm. And all the metadata related, which actually binds these things, will be stored, will be created by FairOS, and that metadata also will be stored in Swarm. And when you index a file and actually say that, okay, I want to index on two fields. Let's say I want to index on the field, type, and I want to index on the field tag, let's say. What I do internally, what we do internally inside FairOS is that you create a prefix tree, or you can say compressed prefix tree, or some people will call that radix tree, for each of the field, and which is like, let's say, if you have like name, NAME, and at the end, the leaf node will have the place in which that particular document starts, right? So it will say that, hey, if you search for this, this document is there at this point in the entire file. It will say what is a block and what is the space in that and all these things. Even though it's compressed, it will still show you that which is the place of that. And similarly, every field that you index will have a separate radix tree, and all these are also stored in Swarm. So so nothing is stored outside, everything is stored in Swarm. So one is the entire raw file is stored in Swarm as small blocks. Blocks are also compressed, and each of the fields will have a separate radix tree. And each of this, the entire data structure will also be stored in Swarm. So if you actually search, let's say if I say, hey, give me a document which has field 1 equal to blah, 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 it will go here, and every point it will go and load this particular part of the tree from Swarm, and then it will find out this last bit, and it'll jump to this place, and it'll get this, only this chunk from Swarm. So it's actually efficient, very efficient in a sense, if you see like that. So if you access something, the index, only that part of the index will be accessed and loaded inside the memory, and only that part of the actual file will also be loaded into memory, and it will be used. Of course, there is an LRU cache inside that, and it will be used. So let me just go and show you a demo. So yes, so this is in a place called api.fairos.io. So you can, I'm doing from my local machine. You can also do it from your local machine, or you can actually install your own Swarm and install your own FairOS and import, or you can access this public data set from there also. I will give you information about my data set so that you could access that in the end. So this is actually connecting to api.fairos.io. So the username is OSM. You don't need to know this, but you can still access it by only using the reference. So there is a pod called OSM. So I'm going to open this pod. And inside that, you will see, a directory called Switzerland. We are slowly planning to have more countries and so on until we'll reach Planet OSM. Right now, we cannot do that because it takes little bit more memory, and I'm trying to optimize the indexing to have very, very less memory and be decently fast enough to access in a user interface. So in this one, you could actually see the actual file, which is swtags.json. So there is, if you actually download the file from OpenStreetMap, you will actually get that in OSM format, which is XML. I have written a small utility to actually convert this into JSON. I will give the path of the utility also. It's just some small 10-line utility, which you can also write in Python. I have written in Golang. You can write in any language. I think there are lots of utilities to convert OSM files to JSON. So it actually looks like this. It's a slightly bigger file, so it takes time to load in VI. So it looks like this. So every row of line is a JSON document. You can see the type here, ID, lat, long, visibility, timestamp, and then actually the tags. The tags will be depending upon what node, what way, what relation. You have different tabs. You have like different tags. So I have indexed this in a separate database called Switzerland. I have indexed two fields. One is type and another is actually tags. Tags is actually a map index. When you say a map index, you don't have to specify what field you have to index. You just have to say that, hey, index this entire tags. So this tags is actually a map, which means it has key value, key value, key value like that. It has key value pairs. So it will take the key value pairs and index those pairs automatically. So you can open this by using doc open Switzerland. It takes some time. So I have already opened this here at this place. So yeah. So let's actually go and see how big the file is. The file is like, sorry. So the file is like 1.6 gigs. And if you actually see the file here in this one, stat sw tags.json, which is the same file. So I have uploaded as 10 MB files, and each 10 MB block is compressed into 1.6 MB. So that is a nice saving that you get. It's like almost 5 times, close to 5 times compression, you can say. So now you can actually run some actual queries on this. You could say count Switzerland. So it will count the number of documents. It's like closely 6.1 million. Let's see here. WC minus L Switzerland is 610, 6163. It's slightly different because some of them will be ignored. I think if they're not good, they're ignored and things like that. But it is approximately 6 million. So you could actually count, for example, using an expression. You can say you count only the nodes where type equal to node. Right, so there's like 1.6 million nodes, and ways are like 4.3 million. Obviously there are a lot of roads and waterways and things like that. Let's do something useful. So there is a command called find. Find will give out, it's, I mean, if you have used MongoDB, you will understand this. It's like get all the documents which match this particular expression. So it will find all the document where type amenity is equal to cafe, and you can give a limit on this one. So let's say I give a limit 5, right? So it will just give me only 5 documents. There are a lot of documents. So what you can see is, did I put it rightly? Switzerland. Let's see if there is an amenity cafe. Amenity, is the spelling right? Okay, A-M-E-N-I-T-Y, fuel. Amenity fuel. If you don't give the limit, it will just give you the first 10 documents. So there is some issue. I don't know what the problem is. As you, I think there is some. Oh, okay. So okay, not type. It's tags. Tags equal to amenity cafe. And you will see, okay, you will see documents which have amenity equal to cafe. Unfortunately, there is only one document. There, I saw fuel just now, FUEL, if I'm right. So yes, so this actually says what is the this says that this is a fuel pump, brand is BP, and octane 95, yes, and self-service, and like things like that. It'll give information about that. So you could even count the number of fuel stations which are there in OpenStreetMap. Okay. So there are like 3,495 fuel stations in this wing. Of using actual OpenStreetMaps. So let me go to Geneva. So I have already gone here, but just to make sure that you guys everybody knows Geneva. Yeah. So I go to Geneva, and OpenStreetMaps shows me there is there is a country, there is a state called Geneva, there is a city, there is a town, village, and all these things. We want to go to the city, Geneva, which is there in Switzerland. So this is having this node ID, and it shows all this information, and with lat long and all other ways. So this is actually a way, if I'm right. Okay, this is actually a relation. So what you see here is a group of relations here, a group of ways and nodes. So there are like 18 members here. So this is a node, way, and all these things. So this forms the entire Geneva, right? So using this data, this is actually drawn as a raster tile. So let's see if we can get this in our database. So what you can do is .get Switzerland. You can just give the number if it's ID. So you are getting all the relation and the map and all these things related to Geneva. There are different ways, there are different tags. Tags are in different, the name Geneva is in different languages. And this is the members, as I said, this is the tags and this is the members. Members have all the maps and nodes that we see here. Okay, so this is not displayed like very nicely. I think the display is like putting 3 dot with an, since it's a big number, I think there is some parse error, but you will get the actual data in the JSON. It's just the displays like this. But you get the entire node, and then the tags, and then all actually the members which is there in that Geneva relation, right? I think you get the idea, right? So this is how you take OpenStreetMaps data, and then you try to show it in your screen. Yeah, so I said I will show you the place where you can just attach it. So if you go to this, my GitHub, there is this thing called OSM. There is a repository called OSM. I have put the file which actually converts the given OSM.pbf. So this is the file that you download from OpenStreetMaps This is like in a protocol buffer format. It's very simple to read this and print all these things in JSON. So this is how I have done it. So yeah, so this is the API gateway, and this is the sharing reference of the pod. If you want to use the OSM pod, you just have to do pod receive and this in your inside your user, and you will suddenly see a pod called OSM, and inside that you will have the database called Switzerland, and you can access it exactly like how I did it right now. I will put this in the Telegram, the support chat, and if you have any, any doubt or anything regarding this, I'll be there in the chat. You can ping me. I sleep slightly earlier than you guys, but anyway, I will try to be awake and answer all your questions. Back to Grigor.
Awesome, Zakur. Thank you very much for this talk. I think there's actually we have quite a lot of things to unpack here. So a couple of questions before we proceed with others. Now, my understanding is that I can now, if I'm developing an app, I basically can just now connect, like do ordinary API calls to this spot and get that data, right?
Yes, it's as simple as that.
Yeah. So, and now this API endpoint, I can set it up myself running on Node, or you set up also API.FairOS. .org, which is, I guess, that's like Infura for FairOS right now?
Yes, it is. I mean, initially we need to have some kind of this thing for people to, just hack around without installing, without doing anything. So this API.io is like a free service that we are giving for now. But
I totally get it. It's like I'm one of these people. It's like where I'm a weekend hobby coder, and then if I just spend my weekend on setting up the whole stack before I can start experimenting, I get tired. So connecting quickly to just API endpoints to get this instant feedback. Yes, I do need that, and I know quite many developers who are saying
the demo from my local machine. I connected from my local machine. No data is there in the machine, but I was actually executing in my local machine.
So maybe a bit of provocative question. Why only Switzerland?
I actually had Afghanistan first, and it's a crazy place. It has a lot of peaks and a lot of military control borders. But I just thought Switzerland is a nice place. Not, I mean, I have not seen it physically, but I think it's a very nice place. But I used it because the size of the index is not small, not very large.
And it's home of Swarm also. It's home of Swarm. So yeah. Yes. No, but it's like why I also mean this. It's like I think we should use now this opportunity. It's actually a call to action to others, and it's a quite I would say also an important moment, as until now within Swarm we didn't speak about a new stakeholder, and this stakeholder could be called like data stewards. So it's not the developers, it's not the node operators, it's the people who know it's important to have certain types and kinds of data in a way that cannot be taken away from humanity. So I think, here, maybe it's an open call to everybody, help out, claim your country, help upload that country, index it, and we then connect, we then create a pod of pods, I guess, right?
Yeah.
Which is the whole world. So if you would like to be let's say, one chief swarm cartographer for a country, please do reach out to us. And this, Zakur, I would ask you if you can stay on, because right now I would also invite Tadej. So it's a good way to also show. Tadej has been working on some really exciting stuff in connection to FairOS. It's an UI, and such an UI could be very helpful either for developers to work with the data sets, the pods, or for these data stewards that I mentioned.
Yes.
So Tadej, thank you for joining us.
Hey, hi.
As I mentioned yesterday, I saw what you are working on, and I think we need to share this already with the world, to see it. And it's great continuation to what Zakur just presented. If you can show us what you've been working on during this hackathon.
Sure. So I've been following Zahur's work for quite some time, and as I saw this beginning of this Liberate Week hackathon, his progress, I said, okay, this is super cool, but maybe people would need like a web front end, instead of CLI, and so where all these methods for the API are implemented in a referenced way, and also to show other developers how actually to use this FairOS DFS. So maybe I'll just share my screen. You see it?
Yes.
Yeah.
Yes.
Okay. So we start with the user. The new user can be created based on the username, password, and mnemonic, and you just can sign up, or you can import based on what you type inside your mnemonic username and password, and then you can check all other stuff. I have this already typed in, so I'll just log in, and now I have. First of all, I can select which gateway do I use, or I use a local host or the one from Zahur, and this list will be and can be populated by users anyway, right? So apps can have this predefined or just allow a user to use whatever gateway they want. So one of the things, maybe I'll turn the book on. So one of the things is, first we have like a list of pods. I can create new pod one, and I can open it, close it, and I can see its contents, and I can sync, and I can delete ones. I can also make a directories inside. This. Oh, there's some problem. Yeah, as I said, this is we didn't. The demo gods are not. Let's try again. Oh, maybe I close it. Huh? Oh, there's something else. Okay. Anyway, I have a pod one ready, and I have few folders inside with files. Mind you that I didn't bother with uploading files because it's more how to do and deal with data, right? So now I have a pod one open, and I have several tables here. Maybe I try to do another one. Yeah, so it's tab 11. So if I choose one, I have 10 records here. I can seek at the start, and then I can just go through all the records. I can put some key with value, put it, I can get it, and if all is well, I should get it also here. Maybe Tilix. No, I'll put them in. Ah, here it is. So yeah, it depends how you search, right? From which index till from start till end. So maybe this could be like this, and just get this one. Yeah, so this is one, right? So these are key value stores, right? So app can put the data into the pods, and then we have like the documents. Again, you can create them. You can create them with the indexes, and select this one, or I put inside, I don't know, some sample data. So this is already inside, and now I can get it out, right? Or I can get, I don't know, 1, 2. I think this is the data that comes out. 4 does not exist. 5. So let's try something, because Zahur added the pod, and I'll receive this pod.
Yeah, you got the part. OSM is the last
Oh,
part.
yes. Cool. So
Yeah, you see Switzerland.
yeah, I have Switzerland, and now I can actually search for it, right? So what was the reference number?
Uh, uh, just go to openstreetmap.org and search for Geneva. Geneva is the only place I know in Switzerland. Yeah, click the city there. Yeah, you can get the index.
I'm getting some errors. I have to open it, huh?
You want to open it. It takes some time to open because it's actually a big database. Yeah, it's open now.
Yeah, okay.
Yes.
That's it.
See how easy it is to get the data.
Yeah. So this is basically like meant like to be a tool where you could manage your own data, right? Maybe the interface, of course, the interface would have to be changed, but the idea is that you could manage like, like you manage the databases on PHP MyAdmin or stuff like that. You can manage most of this data in such a way that's in this project, right?
So basically we can see in future that people won't need any technical skills to actually create and upload data sets for others, right?
Yes. So the idea is, but I didn't come to this yet, right? So this is where we stopped now. So the indexing and searching still needs to be done. But the thing is, here you can, the thing is, you could just like specify some, endpoint where you get the JSON and you insert it, just like get it from some URL. You get it into the browser, and then from the browser you insert it into your own bot, which could be a really powerful kind of a shortcut, right, for normal users. Yeah.
Awesome. Very exciting to see. It's we need to stress again. You started to work on this week, right?
Yes, Tuesday.
So amazing how much you were able to do in such a short time. So yeah, it's really good, and I can see how it can empower people to create public data sets. My kinda, you know, my wish, my big dream is that we would also have interactions then when everybody can contribute to some data set, and at the same time the hash, we get the same hash in a very similar way as we get a transaction hash on blockchain, and we can check that exactly the data that we submitted is part of the data set. And if we think a bit about this, it's like so many applications. It's we see how much people today are mistrustful, how their data is going to be handled and so forth. Really nice. Thank you very much today for this demo. I would actually ask you also to stay on. We have now we have come to the end of the demos. I would invite for also closing discussion and sharing thoughts on free press and permissionless publishing. I would invite Gabriel. If Gabriel, you can also join us. Awesome, great, great to see you. Hello, Gabriel. Thank you, yes. thank you for joining us. So
my pleasure.
It's you know, I'm very happy that you joined us, because you've been actually through the years now a big advocate of permissionless publishing and free press. So you are part of the IOV team, and you've been also working on these matters. Maybe you can share your views with us, and why you think this is important, and how you actually tackle this at IOV.
Well, thank you very much for the invitation. Congratulations to all the demos and all the participants in the hackathon. And as you said, Greg, I believe this issue is very important. I thought it was very important before, and now I believe it's even more compelling. I mean, it's incredible what just happened the last couple of months. You know, we've been in the Bitcoin space, working on smart contracts on Ethereum, on RSK, understanding that there's no going back in the construction of a decentralized finance. And we always kept this idea that, you know, this should be like the cornerstone in order to build a fully decentralized internet, as it should have been in the first place. Now, I'm just completely surprised and I cannot believe the events that happened the last couple of months, which, in my opinion, just make even more compelling and urgent the need of a fully decentralized internet with decentralized publishing and permissionless and censorship-resistant internet. I'm sure you agree, but the internet has become a geopolitical battleground in the last couple of months. You know, the deplatforming of Trump, which on a personal basis I hate, by the way, but it's just, I mean, in Latin America, it just showed every single politician and every single person that whenever these massive tech corporations want, they can disconnect any president or any government or any public speaker or thinker with the rest of its fellow citizens. If they have been able to deplatform the most powerful man in the world, because he was a sitting US president, imagine what they could do with any other president in the world. And I think we are starting to understand the impacts of this. I think even Jack Dorsey was explaining that he was against Twitter having this power, no? And everything that you guys are building or enabling to be built on top of Swarm, I believe is the only hope that we have to recover the internet, because there's so many issues that we could spend hours talking about. Blocking applications from being in the app stores. No, this now has become a very powerful way to concentrate and to censor speech. Delisting or blocking applications such as TikTok in the US, as Trump wanted to do, or asking Apple to include backdoors to spy, maybe Apple users in other countries. Prohibiting public companies to list their shares in different equity stock exchanges. So we are in the same way that the US and other governments started using SWIFT and the financial system as a geopolitical weapon. Now they are moving full on into the rest of the internet. So imagine in a near future when we have a fleet of robotaxis, right? And where people don't know how to drive anymore because it doesn't make sense to go through all the process of just, to drive for fun during the weekends because your car is self-driven. If they can shut you down your GPS or your Google Maps. So that's why I'm so excited to see OpenStreetMap being published on Swarm, because every single piece of the internet that we see as a very naive and, what can they do with this, can become a geopolitical weapon in the future. And this is becoming critical because I do not see, a scenario where suddenly China and the US start getting along and US is cool with China taking the leading role in the global economy. And what other countries or regions such as Europe or Latin America or India would do in this, massive geopolitical power. This is the reason why we at IOV Labs 2 years ago acquired Taringa, which is the largest social network in Spanish in the world, because we wanted to make sure that we have a proof of concept to see what are the building blocks, the infrastructure, open source building blocks required in order to decentralize social networks and then sharing economies. So this is why we built the RSK infrastructure framework, or RIF, which are these building blocks which integrate with decentralized storage, with Swarm and IPFS, decentralized communications, so we can post our photos or videos on the decentralized storage. We can communicate to each other with these communications relayed through the centralized network of nodes. We can share the value with the content providers on decentralized nano payments. We can manage our reputation. Imagine if you want to exclude a group like the Uyghurs in China, you can just tell them, you lose all your reputation in WeChat, or you don't like any particular group or any particular country, just erase their long history of reputation, or just deplatform the people from decentralized marketplaces. So the identity part and the marketplace, the decentralized marketplaces, are also key components of the RIF framework, which will be used as a proof of concept by Taringa and open to any other social network that is willing to be built, fully open source and decentralized. And I cannot believe how much we need these technologies now. When we were talking last year, it felt that we had like 5 years time frame. It's very difficult to be built. And the problem was kind of, there's no one really desperately needing this. Everything has changed. What happened with GameStop, it was, again, another massive red flag of what the current establishment can do if they see their incentives or threaten other power. No, they do not care in openly just screwing the little guy because these amazing Reddit users understood that there was an opportunity for a short squeeze. And I mean, we could discuss this for hours, but what's the value of having these massive hedge funds shorting stocks? And even I'm super upset when they were shorting Tesla, which is, a company that might have its issues and and I'm not saying that everything is perfect, but they're trying to solve global warming. So what's the value of human society of having these hateful hedge funds shorting the only projects that is trying to change the mobility industry and how we burn fossil fuels. So I believe that everything that you guys are doing, and I'm super excited to see, and the projects that are going to come up from this hackathon, I believe that they're crucial for the future of humankind. I feel that we are in a turning point in our existence, that Bitcoin and DeFi and decentralized technologies will be key. It's like Bitcoin showed us that we can have a decentralized, permissionless financial system, and now we need to take that those ideas and just expand them through every corner of the internet. Because in any single point where we have centralization, we're gonna be looking at governments and corporations just using that power to retain their power and just not enable a more open, global and fair society. So if there's a message that I would like to give you guys or leave you is, this is not a nice thing to have anymore. This is an urgent need, and we should take our work and our technology extremely seriously, because when you live in a country where everything seems to be working, like Switzerland, it's very difficult to convince people that Swarm is very much needed, or a decentralized social network, or even Bitcoin. Now, when you live in Argentina, or when you live in Venezuela, when you are censored by your government, you cannot trust your institutions, as I sadly believe most of us will realize very soon that it used to be a problem in the emerging markets and corrupt governments, but now we're seeing that the corruption is everywhere. And it was just that there were no enough power at risk. But when the shit touches the fan, we're gonna be very lucky and thankful that pioneers such as the Swarm team have been working on this for so many years. Because if we want to start building this in a year from now, it's going to be too late. So all this hard work that you and the team and the whole ecosystem have been taking in the last couple of years, I think are going to be extremely important for our society, if we want to build something that is better of what we had. Because if we do not do anything, if we just retire, if you go on holidays, then it's very clear that we're going to the Black Mirror scenario. No, it's the guys in power will just try to get even more information, abuse even more from users, have more surveillance. There is no roof for the amount of surveillance and control that they would like to have on global society. So it's up to us. It's a community effort that we need to work together as a Swarm to make sure that a better society is possible. So just congratulations. I'm very excited to see all the projects working on this hackathon.
Thank you. It's like you said, it's I deeply believe that not a single project can make a change. We can only make change through collaboration. It's only with united forces, and where we see how we can unlock these synergies, that we can shift the needle into the other. And it's like you said, it's in this regard, maybe also COVID. The situation with COVID was quite a learning experience, because when I look, okay, most of my life I lived here in Slovenia, and it's nice country, all good. But basically COVID made us realize how fragile everything is. We are right now, I don't know, it's like for 3 months we have curfew. Curfew was a concept I read in the books from Second World War. It was too abstract for me to think of. And Slovenia, it's such a small country, you know, if you take the longest route, it takes you 4 hours to cross the whole country. And we have restricted movement. I cannot visit basically my parents right now without breaking the law, and they are 1 hour drive away from me. And it's when we see like these kind of things, or like 3 years ago, what was happening in Catalonia, in the middle of Europe, where repression was happening. It's like, it makes us aware it's very fragile. And as you said, I also remember like the beginning of the year, I was looking at the things happening and the discussions that were started by the mainstream media. You know, I was just traveling, turning on in the hotel CNN, and they speak about censorship resistance. And I was like, okay, which universe did I wake up already? It happened so fast. So yeah.
Yes,
it's
and also I think the fake news problem, it's a massive thing that we need to find a way to tackle, because what I feel now is that regardless how smart you are, how much research you've done, it's very difficult to tell what is truth and what is lie. And we are so easily manipulated that I also believe that there's a lot of work and contributions that could be done through this decentralized movement on just curating those news and giving us back some level of truth. Like in Latin America, there was a massive campaign against the Russian vaccines now, and people rather die than getting the Russian vaccine. And now the Russian vaccine is the only thing we can get. So and there was some extra information. So now everybody wants the Russian vaccine. But it's so easy to manipulate in pursuit of a profit, you know, a pharmaceutical lab, a geopolitical just comment from our leaders. And we've realized that our leaders lie openly to the public with just no consequences. So unless, I'm not saying that we can fix this, but unless we fix it, no one else will. Because there's so much power and so many interests in not saying the truth and using the social media to manipulate people that we cannot trust them anymore. We know that they want to manipulate us.
It has become part of the playbook, and it doesn't matter to which option one subscribes or anything. Everybody's doing it. It's this global fight for attention and buying into this kind of version of reality that fits someone's agenda. So yeah, it's unless we have really uncorruptible and verifiable data, technologies that put us in control, I don't think the matrix scenario will be good.
Yeah.
You know,
so the
yeah.
stakes are very high, and everything that we've been building over the last couple of years, it's becoming more and more of an urgent need. So
you know, it's been so a bit of my a bit of my background comes from user modeling and these things, and it's this was last year. I was preparing for one talk, and I was looking up on Google Scholar how many references Bitcoin has, Satoshi's paper has, and how many references the work of Mikhail Kosinski has. He's one psychologist that also Cambridge Analytica draws upon his research. And it's, you know, like his reference count is dwarfing what Satoshi has. And this shows, as also Harari is telling, today's sport, not just by governments, it's also by corporations or in general, is hacking the human mind. And we might even think that it's only the Apples and the Googles and these guys who are bad, but it's even the small user using Facebook ads who's part of the game, who actually also is, because of the technology and the environment we have, that also the good guys are also forced to be the bad guys in order
Yes,
to stay
because
competitive. Yeah.
yes, and the problem, I think, the underlying problem, it's really to the incentives, the economic incentives that capitalism brings onto us, right? When you have shareholders that are only asking for profit and to maximize those profits, then you're basically telling those management teams that the ecology is not important, that the humankind is not important, that the way we live, that health is not. I mean, if you work in a pharmaceutical lab, your shareholders don't care how many people you saved; they care how much how much money you made. And this is one of the things that I also like the most about decentralized ecosystems, that we've been able to create a model that maybe it needs perfection, no, it needs to be improved, but it could present an alternative to just raw capitalism that we've seen in the past, where things such as global warming are not factored in. So this is a problem as well. No, when the world and the main organizations are just seeking to maximize profit as its only concern, then it's when everything else falls apart.
Yeah, then it becomes a race to the bottom. Yes, I'm looking at the time. We've been actually quite over time, but I think we could speak for a lot longer. However, unfortunately, I think we need to wrap up. Maybe if there's any questions from the audience, I would ask, this is the time to speak up and we try to answer. So any questions? I guess no. I guess no. So with this, I would conclude today's session. Gabriel, thank you very much for joining. Zahur, Ben, today, thank you for the demos. Everybody, thank you for taking the time and joining this call. And please hit us up on our usual channels, Telegram, Mattermost, ask us anything. We are here to help you. And let's build together a new and nice future. Thank you. Bye-bye.